Just as a general rule for 30, 60, 90s, 45, 45, 90, like word problem types, generally because a square is 90, 90, 90, if you're drawing a diagonal, you're creating an isosceles triangle. And if you're creating an isosceles triangle, you're creating a 45, 45, 90. So usually if you see a square, consider your 45, 45, 90 triangle. Okay? If you see a rectangle, not all the time, but if you see they're making a rectangle and they're making a diagonal and you see there's some form of 30 or some ratio that's involved there, this would probably be 60. Try to consider that as a 30, 60, 90. So generally your rectangle will be a 30, 60, 90, and your square would be a 45, 45, 90. Here we're working with 45, 45, 90, ratio x square root of 2. They're giving us the side opposite 90. We know 42 is equal to x square root of 2, divide square root of 2, divide square root of 2. 42 divided by square root of 2 times, we have to conjugate. We can't leave this square root of 2 on the bottom because it's not a real number. We want to conjugate 42 over square root of 2 over 2. You can reduce to 21 square root of 2. And then a key piece here you might see, just to take a look at the calculator, is that they may ask for a decimal form of this. You simply would just do 21 times square root of 2, and you get an answer about 29.6, or you could say 30. I'll post these up after we're done here. Here's another square. We're looking at this square, okay. This is our 45, 45, 90. This is one, when they give you the 45 or they give you the 30, it's pretty easy because you're just multiplying. This is your x. So you're just multiplying that square root of 2. It's whatever this is next to the square root of 2. So basically what that's telling you is that this side here is 9 square root of 2. So if you're adding all four of these sides, it's like you're adding 9x 4 times. So basically you end up with 36 square root of 2. And if you're, again, doing it on a calculator, you could just do 9 square root, 9, oh, no, try again. Square root of 2 let's delete that. Right arrow. And let's just multiply that 4 times, and you'd get an answer about 50.9. So 9 square root of 2 times 4 would give you this, and then put that on your calculator, you'd end up with an answer about 50.9 or about 51 here. Here's a 30, 60, 90. Here's one where you actually have to go through the problem and see what they're giving you, try to identify some of the given information. Silvio rides his bike 3.4 miles from his house to school. Here's house to school. We're identifying. Now, if they're giving you a decimal, odds are they're just wanting to use a calculator kind of with your ratio. After school, he rides his bike to community center. How far is the community center from Silvio's house? This actually piece of information is, not to say useless, but it's not really totally pertinent to the question. That important, we'll say. 30, 60, 90, side opposite 90 is 3.4. They're looking for the side opposite 60. So this is a case where you have x square root of 3, 2x. What I want to do is actually go back to my 30 to get my x. So 2x is equal to 3.4. So I could divide by 2 here, right? 1.7, x is equal to 1.7. And then if I want the side opposite 60, I'm going to multiply by square root of 3, so 1.7 times my square root of 3. I could just do that here, times second. It's the inverse of your square, 3, 2.94 would be the answer for this here. That would be my side opposite. And this is kind of the idea of like you're working more so with decimals. I don't find this to be terribly hard, but I guess some of this diagram could confuse you because you have this piece here. If this is x, basically this is x here. This is your 4.4. Here's your 60. They're giving you the side opposite. They're giving you the side opposite 30. That's an easier question. If they're asking the side opposite 60, you're just multiplying square root of 3. So that's your 4.4 times square root of 3. Boom, 7.6. I got that by doing 4.4 times square root of 3, gave me that 7.6.